Frequency domain field monitors return data in the frequency domain by taking the Fourier transform of the time domain fields. By default, CW normalization is applied, which means that the data is also normalized by the spectrum of the source pulse to give the result as though the source spectrum is uniform. In other words, by default, the result from a frequency domain monitor at a given frequency point is the response as though the source is injecting a continuous wave at the specified frequency with amplitude 1. You can review the CW normalization method in the FDTD algorithm section of this course. There are two available types of frequency domain monitors: the frequency domain field profile monitor and the frequency domain field and power monitor. The only difference between the two monitor types is the spatial interpolation method used. The profile monitor uses the specified position interpolation, and the power monitor uses the nearest mesh cell interpolation method. In most cases, the results from these two monitors will be very similar, and we recommend using the frequency domain field and power monitor unless you're an advanced user and have a detailed understanding of the monitor interpolation options. By default, the frequency domain field monitors return E and H field components as well as T, the net power transmission through the monitor. However, you can also choose to record the pointing vector components in the Data to Record tab. Transmission results are only returned if the monitor type is linear or 2D if running a 2D simulation, or for a 2D monitor if running a 3D simulation. The transmission result is only available if either the pointing vector or output power is selected to be recorded in the Data to Record tab. If all E and H field components are recorded by the monitor, it's also possible to project the fields from the monitor to get the far-field angular distribution. This result is something that is calculated as a post-processing step after the simulation has been run. So when you first try to visualize the far-field result of the monitor, if it hasn't yet been calculated, a window will pop up asking you to select the settings that you want to use for the far-field projection calculation. Examples of when you might want to get the far-field angular distribution are if you're interested in the radiation pattern of an antenna or the scattering pattern from a particle or defect. In the next unit, we will demonstrate the far-field projection settings in the graphical user interface. There are settings in the Spectral Averaging and Apodization tab for frequency domain field monitors, which allow you to choose to calculate and return a full or partial spectral average result, or return field results from a specified portion of the time signal by applying apodization. Apodization is useful if you want to get the field profile of resonant fields without including the fields from the initial source pulse that's injected to excite the resonance, or effects of ending the simulation early, truncating the time signal. There's more detail about how and when to use these advanced features in the related links below.